All right, so let's go on to the next section, which is perimeter defenses, physical security. So 3-foot fences are just a deterrent intended to sort of remind people not to walk there. An 8-foot fence with barbed wire on top is considered preventive, where many people actually physically cannot get over that wall. There are various kinds of gates, like deterrent gates, and then there's a crash gate, which is so strong that it will stop a car ramming into it, and those are expensive. But then there's bollards, which are just to stop people from driving into an area where you don't want them going. They're often temporary, and so on. This became real important after the Oklahoma City bombing, and many people now decided that they have to put up bollards so nobody can drive a car close to your building in case you were to bring in a whole truck full of a bomb, which is what happened there. So you can have lights. Lights can be deterrent, just to make people feel reluctant to sneak in at night, or detective, in that they're associated with cameras or people are watching. And so closed circuit television has been around for a long time. In the old days, they were analog, real-time cameras that somebody would watch. Now they're mostly digital with charge-coupled devices, and they run and often save the tape, of course. Almost everybody's got these things these days. Then there's locks. The old-fashioned mechanical lock has something like 7 depths of position for each of these parts you can cut out, which I forget the name of, where the pins go. And then this pattern of pins has to have the right amount of depth at every spot, and then this will line up so you can turn the key. So it's a simple mechanical system. Yeah, that's right. Yeah, back in the old days, they just had full rush hour traffic right in front of the White House. Yeah, and nowadays they keep them away. All right, so you can pick a lock by just reaching in with a tool and lifting these pins and putting a little bit of tension here so that when one of them hits the right height, it will turn just a little bit and catch it in the next one. So with skill, you can pick a lock pretty easily. And even with just a half-hour training, anybody can learn to pick the kind of lock that we got on our front door, and we do it all the time in our security classes. And they do it at all the DEF CON and everything. They teach people to pick locks. That's where I learned. It's very interesting, and it teaches you how insecure the average lock you're putting on your front door is. Then there are bump keys. You just shave every one of these down to the bottom, and then you just tap it with a screwdriver, and that causes the pins to sort of bounce randomly, and eventually they'll hit the right spot and turn, and it only takes a couple of minutes typically. And then there are these guns based on the same principle that just ratchet something and randomly move the pins, and you can put in locks that way. So then there's master locks, master keys. Often, every lock, like at a hotel, there will be one master key that opens every door, and there's some locks have a core key. And then there's these combination locks. These things look good, but in fact there are not really very many combinations of them, and there are a bunch of ways to find the combination pretty easily by sort of pulling on this and finding a spot where it lets up a little. And if you have button or keypads, those are also weak in practice because you can tell which keys people have been pressing by the grease of their fingerprints, and after a while they wear down, so you know which keys to use. And of course you can just watch somebody else with a camera or a telescope or looking over their shoulder and learn what the combination is as they press the pins. Smart cards are what we now all have for credit cards. They have an integrated circuit on them, so there's an actual computer chip on the card which can do a sort of HTTPS type handshake. And now there's magstripe cards, which is the older system where it just has a static bit of information on a magnetic stripe, but these smart cards do a more complicated cryptographic handshake. And so these are the CISSP. Department of Defense has been using these, and you would put these in a reader to log into your computer or into a reader to go through a door. If you open a door, somebody else might follow you through the door without authenticating. That's called piggybacking. So you can have policy forbidding it and tell all your people that they really aren't allowed to let anybody do that. And you can have man traps, which are chambers with 2 doors, where you open the first door, but now you're in a little place like an elevator, and now the second door will only be opened by the guard who's looking in a window to make sure that there's really only one person in there. And then there's turnstiles, like they have at BART, where those little rotating things are intended to make sure only one person goes through at a time. One problem is you have to have some way to let people out of these traps in an emergency, like a fire. and that may be a weakness to get in. And then, of course, if you want to try to stop people from bringing forbidden things in, like guns, then as we know, TSA tries this, and it's not very easy, especially if they're not bringing a big block of metal like a gun, but they're just trying to sneak in something like an SD card. It's very hard to detect that. Then there's motion detectors that send out some kind of signal and measure the reflected signal to see if somebody is moving around. And there's photoelectric sensors that send a beam of infrared light across an area and then notice if somebody goes in there. And that can set off a burglar alarm or open an exit door or whatever you want. There's magnetic door and window alarms where you have to have all the windows shut, and then there's a closed circuit, and the alarm goes on, and if anybody breaks that because they're breaking in the window, then it sets off the alarm. You have doors. Of course, you don't leave the hinges on the outside because somebody can tap the pins out of the hinge and get in. You can trigger motion sensors by inserting objects under the door. Students are trying this at the college with me. We found several doors at the college where we can get away with these tricks. You reach underneath and wave something around on the inside, and it thinks that means there's a person on the inside trying to get out, and it opens because of fire safety. The windows are, of course, weak. You can shatter them to get in, but you can put stronger glass. It's either bulletproof intrinsically or has wire mesh, or even made out of a shatter-resistant material that you use in race cars and airplanes, but that's more expensive. Walls often don't really go all the way from the slab of the floor to the slab of the ceiling. There are raised floors for things like wires to go under, and there are these drop ornamental ceilings, and there's things up there like heating ducts and wires and lights in a normal office building, so you can climb up over that and get over the walls. So you shouldn't allow that in a secure area. You have to make sure that your walls really go from slab to slab. You have different kinds of guards. The kind of guard you'll see at Safeway is just like a mall cop. They are just there to observe and report. They are not going to stop people from stealing things or leaving or fight with anybody. They are just there to report and to serve as a visible deterrent. The more professional guards, of course, actually have military training and can actually fight. They're more expensive, and you only use them in more secure locations like military bases. Dogs are considered very deterrent. Most people, if they hear barking, they will decide not to burgle the house. So they're detective and deterrent controls. But of course, if your dogs are not trained well enough, they might hurt people or kill them, and then you might have lawsuits. Your visitors should be wearing badges, so you know they're authorized and people know that there's a visitor and they should hide the secret stuff. So if you use the same badges over and over, and then someone could just keep the badge and come back again later or transfer it to an unauthorized person. So you might want to use time-based badges, like badges that have a different color for every day or something, so an old badge can't be reused. So your site selection matters. Things like hills, valleys, and trees. You typically want to clear all the trees and bushes away from your front door so nobody can be hiding in them. And you consider the environment, like the amount of crime in the neighborhood will matter. Data centers, you often avoid marking them. You do not have a public sign or anything. If you do not want public people going there, you're not offering anything for sale to the public, then you don't put any sign on it, just an address, so it's not obvious that you're doing something in there that's important, like running a server farm. If you have part of a building, then whoever's rented the other part affects your security. If they are sloppy and not locking the door and doing unsafe things, then that might let people in the building who then can break into your area. Your wiring closet must be secured because, of course, anybody that can get in your wiring closet can create a denial of service by turning off the stuff, or they can insert objects in the middle, and now they're performing a man-in-the-middle attack. Now they're intercepting your traffic. So server rooms and wiring closets need to be physically secure, and server rooms also need environmental controls to make sure they're not getting too humid or dry or hot or cold. You have to store your media. Your backup tapes, for example, have to be somewhere, and they have to be off-site so that if the whole building burns down, you still have your backups, and they have to be controlled so people are not stealing the tapes, and so the tapes are not getting exposed to high temperatures and degraded. All right. And then you got defenses of your system. So if all of your other defenses have failed and an attacker has somehow gained physical access to your servers or your media, you can have more layers of defense then. You track your assets, and you have port controls to restrict USB ports and network ports so people cannot plug in unauthorized devices. And then you have environmental controls. Your electricity might fail. There's various flaws that happen in the normal electricity in the wall, and all these are, of course, bad for servers. So you have surge protectors to stop the worst spikes, or UPS supplies that actually have a battery and provide power for some limited period of time, even when the power goes out, so you have enough time to orderly shut down the system, or enough time to turn on your generator. And now you can continue to provide power from your generator as long as you can get fuel to the generator. And this is what places do, like hospitals, where they really don't want to stop a surgery because the power went out. They use a UPS for the first 10 or 20 minutes, and then they use a generator, and then they can just keep going until they run out of fuel. All right, then you got electromagnetic interference. If you have multiple wires like Ethernet cables, you have 4 pairs of wires, so the signal from one wire leaks to some extent into the other wires through radio. Unshielded twisted pair is most susceptible to external EMI, so if you run it past a fluorescent light fixture, that will create interference with the digital signal. Shielded twisted pair has a layer of tinfoil on the outside to protect it. And the best is fiber optic. Fiber optic does not have this problem at all. It's just pulses of light going through the glass, and they do not produce radio, and they do not leak from one strand to the next, and they do not get affected by electrical signals from the outside. Heating, ventilation, and air conditioning is important. You should have positive pressure in your building so that water will be pushed out and won't be leaking in. And your data center should have humidity near 50% and a temperature at whatever the recommended rating is. They used to keep them pretty cool, 60 or 70. Google tried raising them up to like 90 degrees and decided it was okay. But anyway, you do need to control the heating so they don't burn up. Static electricity is bad. If the humidity gets too low, then you get static electricity, and that causes sparks that damage the components. And if you have the humidity too high, then you get condensation on it and you get corrosion on it. That's why you want to keep the humidity in the middle, near 50%. You might have dirt and dust that will clog up the fans and such, so you want to keep it relatively clean in your server room. And you got to have heat and smoke detectors. So you can have basically thermometers that detect that it's hot, or smoke detectors that detect smoke particles in the air, or flame detectors that detect the light. Any of these things will now turn on an alarm and turn on your sprinkler system. All right, so you have to have evacuation routes for your people, and you have to have plans of how the people should get out of here, and fire drills so they practice leaving the room, and consider handicapped people who can't go down the stairs. And if the elevators are out of action, which you normally don't want to use elevators in a fire, you have to have some plan to evacuate those people. So you have emergency warning systems for bad things that might happen. Some kind of alarms around the place you can tell people to evacuate because something bad is happening. And then you got fire extinguishers. A is just water for like wood and paper. B is for flammable liquids like gasoline and grease. C is for electrical equipment. D is for combustible metals, which are not very common. And K is for cooking grease. So those are the rating symbols you'll see on a fire extinguisher. So that's what fire, you want to either reduce the temperature, deny it oxygen, deny it fuel, or interfere with the chemical reaction to stop the fire. So water, of course, is good for paper or wood, but it's not good for electrical equipment. It'll short it out. Soda acid, dry powder, wet chemical, these are the various other kinds of fire extinguishers that are common. You might want to use a gas in your server room so you don't mess up the equipment. So you can put in an inert gas, but if you fill the room with CO2, for example, that will stop the fire, but it will also kill the people that are in the room because there's no oxygen left to breathe. That's why people prefer to use halon or modern halon substitutes, which can suppress the fire, but they still leave enough oxygen in the air so the people don't die. The problem is halon is really bad for the ozone layer, so it has banned like other refrigerants. And now they use these new techniques like argon or FM200 or FE13 or InRegen are the modern replacements for halon. So you have a countdown before deploying these things so personnel can evacuate, and it also lets them cancel it if it's some kind of false alarm. And you have sprinkler systems, from the wet pipe, where there's water actually in the pipe, or a dry pipe, or a deluge, which dumps a large flow of water out quickly when the valve opens, or ones with 2 triggers to try to avoid setting out water when you don't really have to because the water is going to damage what's in there, like a museum with paintings and stuff. All right, so there's one more Kahoot, and that's the last bit for today. So that's 3I, which is here. All right, I'll wait a little while longer. I think we got up to 9 or 10 last time. Well, looks like 8 is the number. Okay. All right, where's the deterrent here? All right, 3-foot fence is a deterrent. Doesn't actually stop people, it just sort of encourages them not to go over it. All right, when you shave the keys down to the lowest position, what have you got? That's a bump key, good. All right, and how about a smart card? That's the ICC, all right. All right, and which fire extinguisher has water in it? A, in fact, it often has a soda acid or something, but it can have just water in it. All right. All right, and what's the countermeasure to prevent EMI? All right, fiber optics are the best. Then electromagnetic interference will not affect the data. All right. All right. All right. Well, 4D42 has won twice, but I don't know who it is. If they don't give me a real name, they're not going to get their points. All right. So let me... All right.